Children, now let us continue the chapter polynomials. Now let us discuss about the remainder theorem and factor theorem and also some examples based on the remainder theorem and factor theorem. Now what is remainder theorem? What is the statement of the remainder theorem? So let us state the remainder theorem. Let p of x be any polynomial of degree greater than or equal to 1 and let a be any real number, a be any real number. If p of x is divided by the linear polynomial x minus a, then the remainder is p of a. If p of x is divided by x minus a, then the remainder is p of a. Now let us take one example here. P of x equals 2x square plus 3x plus 1 is divided by x minus 3 here. Here p of x is 2x square plus 3x plus 1 and it is divided by x minus 3. Then what will be the remainder? Then the remainder is p of 3. Here a is equals to 3. So p of 3 is the remainder. So let us find the remainder here by using the remainder theorem. So you take p of x equals 2x square plus 3x plus 1. Then the remainder is p of 3. That is equals to 2 into 3 square plus 3 into 3 plus 1 it is. Then p of 3 is equals to 2 into 3 square is 2 into 9 it is. Plus 3 into 3 is 9 plus 1. P of 3 is equals to 2 9s are 18 plus 9 plus 1. So P of 3 is equals to 18 plus 9 is 27 plus 1 is 28. So you got the remainder 28 here. Here the remainder is 28. Now let us verify this by long division method. So you take the here p of x 2x square plus 3x plus 1. This is divided by what? X minus 3. Let us divide 2x square plus 3x plus 1 by x minus 3. Let us verify whether the remainder is 20 or 28 or not. Now here there is x, here there is 2x square. Therefore you multiply x minus 3 by 2x because x into 2x becomes 2x square minus 3 into 2x becomes 6x. So you multiply x minus 3 by 2x and x into 2x is 2x square. Then minus 3 into 2x is minus 6x here. Now you know the method of subtracting here. Change the sign here. This minus 6x becomes plus 6x and plus 2x square becomes minus 2x square here. So this 2 cancels. This is plus 2x square and this is minus 2x square. Then in the plus 3x, this is plus 6x. So you will get 9x. Now you take that plus 1 here. That becomes 9x plus 1. Now here it is x, here it is 9x. So you multiply x by 9 here. Multiply x minus 3 by 9, that is plus 9. Then x into 9 is 9x. 9x and 3 into 9 is 27, that is minus 27. So it is minus 27. Again you subtract, then change the sign, this becomes minus, this becomes plus. So 9 becomes cancel here, 9x becomes cancel. So 1 plus 27 you got 28. So this is the remainder here, that is r of x you can take, that is the remainder. Therefore you can say that here p of 3 is 28, which you got the remainder 28 by the long division method. So without dividing, with the help of the remainder theorem, you can get the remainder. Next, let us take some more example here. Take example 2. That is, if p of x equals 3x square plus x minus 1 is divided by 3x minus 2, then the remainder is p of 2 by 3 here. Here it is 3x minus 2. So if you take 3x minus 2 means here if it is divided by 3, that becomes x minus 2 by 3. So it becomes x minus 2 by 3. If you take, so here this is in the x minus 2 by 3 is the form of x minus a. So the remainder becomes 2 by 3. So you find the remainder here. You take p of x equals 3x square plus x minus 1. Then p of 2 by 3 is the remainder. Then it is 3 into 2 by 3 whole square plus x means 2 by 3 minus 1 here. Then that is 3 into 2 by 3 whole square is 2 square is 4, 3 square is 9. That becomes 4 by 9 plus 2 by 3 minus 1 it is. Next here 3 ones are 3 threes are. So it becomes 4 by 3 plus 2 by 3 minus 1. 1 means you take 1 by 1. And the LCM is here 3. Then 4 remains 4 only because 3 ones are 3, 4 ones are 4. 3 ones are 3, 2 ones are 2. And here 1 3s are 3, 1 3s are 3. So it becomes minus 3. Then it becomes 4 plus 2 is 6. 6 minus 3 is 3. 3 by 3. So p of 2 by 3 you got 3 by 3 that is 1. 3 by 3 1. Now let us verify this by the long division method. So you take 3x square plus x minus 1 that divided by what? 3x minus 2. 3x minus 2 divide it. So here it is 3x square, here it is 3x. So it must be multiplied by 3x into x. 3x into x is 3x square. 3x into x is 3x square. Next 2 into x is, that is minus 2x. Minus 2x. Next you change the sign. This is minus, this is plus. So this 2 cancels. Plus 3x square minus 3x square cancels. Now plus 1x plus 2x, that becomes 3x. Minus 1 you take below. Next here also 3x, here also 3x. So you multiply 3x minus 2 by 1. That is plus 1. So 3x into 1, that is 3x. Next 2 into 1, that is 2 minus 2 here. Then change the sign. This is minus, this is plus. So plus 3x minus 3x cancels. Minus 1 plus 2 is 1. So see here you got same value. That is remainder. R of x you take. Symbol is R of x here. So here the remainder what you got by the remainder theorem is same as the remainder you got by the actual division. That is by the long division method. Now let us take some example more here. Some more example you take to verify the remainder theorem here. Now here the third one is, if p of x equals 3x to the power of 4 minus 4x square minus 3x minus 1 is divided by x minus 1, then the remainder is p of 1. So here a is equals to 1, therefore the remainder is p of 1. So you find the remainder by using the remainder theorem here. That is p of x equals 3x to the power of 4 minus 4x square minus 3x minus 1. Then the remainder is p of 1 is equals to 3 into 1 to the power of 4 minus 4 into 1 to the power of 2 minus 3 into 1 minus 1 it is. Then it is 3 into 1 to the power of means 3 1 to 3 ones are minus it is 4 ones are minus, then it is 3 minus 4 minus 3 minus 1 it is. Then it becomes, you can cancel this 3 and minus 3 because they are positive 3, negative 3. Then the answer is here, P of 1 is equals to minus 4 minus 1, add them and put the negative sign. The remainder is here minus 5. Remainder is minus 5. Now let us verify by the actual division, that is by the long division method. So you take 3x to the power of 4 minus 4x square minus 3x minus 1 divided by x minus 1. Now here x is here, here there is 3x to the power of 4. So you must multiply x by 3x to the power of 3. So you must multiply it by 3x to the power of 3. You know that x into 3x to the power of 3 is 3x to the power of 4. 3x to the power of 4. Next 1 into 3x to the power of 3 is, that is minus 3x to the power of 3. Then so change the sign here, minus, it becomes plus. So this 2 cancels. Then what is remaining here? You know that here it is second power, here is third power. You can't add and subtract, so you write separately. So you can write 3x to the power of 3 separately minus 4x square. Then you got 2 terms here. Then here it is x, here it is 3x square. So you must multiply x by, that is plus 3x square it is. X into x square becomes x cube. And x into 3 becomes, 1 into 3 becomes 3 it is. So x into 3x square is 3x cube. Now you multiply x by 3x square, you will get 3x to the power of 3 and minus 1 into 3x square, that is minus 3x square it is. Then change the sign, plus it is plus, cancels, and minus 4 plus 3 is minus x square. Minus 4 plus 3 is minus 1 it is, x square, minus 1 x square. You take next 3x below. Again here minus x square means you must multiply it by minus x. X into minus x is minus x square. So you write minus x square minus x square, minus 1 into x is, that is plus x. So change the sign here, plus minus x square plus x square cancels. Then minus 3x minus 1x is, that is minus 4x. Then you take that 1 below. Now here it is minus 4x, here it is x. So that x must be multiplied by minus 4 it is. So write minus 4. So x into minus 4 is, x into minus 4 is minus 4x. Then minus 1 into minus 4 is, that is plus 4. So change the sign, minus 4x plus 4x cancels here. And here the sign is minus because you have to subtract. Minus 1, the sum of minus 1 and minus 4 is minus 5. So here you got the same value as the remainder what you got by the remainder theorem. Next let us take the next one example. If P of x equals x cube plus 1 is divided by x plus 1, then the remainder is P of minus 1. See here, x minus a is equals to x plus 1 is means, that is x minus a is equals to x plus of minus 1 it is. X minus of minus 1. Therefore, you can have a is equals to minus 1 here. So here there is plus means you will get that is a value becomes minus. So here the remainder is p of minus 1. Here as it is divided by x plus 1, the remainder becomes p of minus 1. If it is x minus 1 means it becomes p of 1. Here it is x plus 1. X plus 1 means the remainder is p of minus 1. So the remainder is p of minus 1. Now you verify here what is the remainder. P of x equals x cube plus 1. Then p of minus 1 is the remainder. So it is minus 1 whole to the power of 3 plus 1. Minus 1 whole to the power of 3 plus 1. You know that minus 1 to the power of 3 means minus 1 into minus 1 into minus 1. Minus 1 into minus 1 into minus 1. So it becomes negative 1. Minus 1. So you take p of minus 1 is equals to minus 1 plus 1, that is equals to 0. So p of negative 1 is equals to 0. So what is the remainder here? 0 is the remainder. 0 is the remainder. Now let us verify by the long division method. X cube plus 1 divided by what? X plus 1. X plus 1. Now see here it is x. Here x cube is there. So you must multiply the x by x square. To get x cube, x must be multiplied by x square. So x into x square. Multiply both the terms by x square. Then x into x square is x cube plus here 1 into x square. 1 into x square is x square it is. 1 into x square is x square. So here change the sign minus because we have to subtract. So change the sign minus. So these two cancels. Now here these two are unlike terms. Write them separately. First you write minus x square plus 1. You got minus x square plus 1. Minus x square is there. Here x is there. So x into minus x becomes x square. That is minus x square. So write x into minus x is minus x square. Then plus 1 into minus x is minus 1x. Again we change the sign. This is plus. This is plus. Cancels here. Then again here you separate 1 and 1x. That becomes 1x plus 1. 1x plus 1. Now here there is 1x. Here also there is 1x. So you multiply x by 1. So it is plus 1. X plus 1 into 1. So x into 1 is 1x. Plus 1 into 1 is 1. Change the sign and cancels here. The remainder is 0, which you got by the remainder theorem. So without dividing, we can get the remainder by using the remainder theorem. This is about the remainder theorem. If there is a question to find the remainder, then you can use the remainder theorem to find the remainder. No need of dividing it. So let us discuss about the next one, that is the factor theorem. So what is factor theorem? If p of x is a polynomial of degree n greater than or equals to 1 and a is any real number, then x minus is a factor of p of x if p of a is equals to 0, or p of a is equals to 0 if x minus a is a factor of p of x. Here factor means the remainder is always 0. Remainder is 0 means the given polynomial is a factor of the given polynomial. That is b1 binomial is a factor of the given polynomial. Here x minus is a binomial. If x minus a is a factor of p of x, when it is factor if p of a is equals to 0. If p of a is equals to 0, then x minus a is a factor of p of x. That is here about the factor theorem. So let us examine whether x plus 2 is a factor of x cube plus 3x square plus 5x plus 6, and also one more polynomial is there, that is 2x plus 4. Here we have to verify that whether x plus 2 is a factor of these two polynomials or not. First one is the polynomial having 4 terms. Second one is the polynomial having 2 terms. Now here x plus 2 is a factor means the remainder must be 0. Here what is the remainder? Here a is equals to minus 2, that is p of minus 2 must be the remainder. If it is 0 means then you can say that x plus 2 is a factor. So you take first one, p of x is equals to x cube plus 3x square plus 5x plus 6. Then here x plus 2 is a binomial. Then what is the remainder? Remainder must be equals to what? Remainder equals p of minus 2 it is, because here x plus 2 is there means that is x minus minus of 2. So p of minus 2 is the remainder. So you find p of minus 2. P of minus 2 is equals to minus 2 to the power of 3 plus 3 into minus 2 to the power of 2 plus 5 into minus 2 plus 6 it is. Then minus 2 to the power of 3 means minus 2 into minus 2 into minus 2, that is minus 8, negative 8, plus 3 into minus 2 whole square means minus 2 into minus 2, that is 4, and plus 5 into minus 2 means that is minus 10 plus 6. So it is negative 8, 3 4s are 12, minus 10 plus 6. Then you can add this negative, minus 8 minus 10 together, plus 12 plus 6 together. So it in sum of these two is minus 18, plus sum of these two is 18, minus 18 plus 18 is 0. So you got p of minus 2 is equals to 0. As p of minus 2 is equals to 0 means you can say that here x plus 2 is a factor of, therefore as remainder p of minus 2 is equals to 0, x plus 2 is a factor of what? X cube plus 3x square plus 5x plus 6. X cube plus 3x square plus 5x plus 6. So x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. Next here we have to verify that whether x plus 2 is a factor of 2x plus 4 or not. So you take p of x equals 2x plus 4. Then again here it is p of minus 2 only because the same binomial. Then you take p of minus 2 is equals to 2 into, in the place of x you put minus 2, negative 2 plus 4. So p of minus 2 is equals to 2 into minus 2 is minus 4. 2 into negative 2 is negative 4 plus 4. You know that minus 4 plus 4 is, that is p of minus 2 is equals to 0 you got. Therefore what you can say that here x plus 2 is also factor of 2x plus 4. Therefore x plus 2 is a factor of 2x plus 4 as the remainder, remainder p of minus 2 is equals to 0. In this way, by using the factor theorem, you can verify whether the given binomial is a factor of given polynomial or not.